Good morning, everyone. Good morning, Sage. All right, let's get going, I guess. We've got a couple of new pull requests here. Looks like probably the two here that are kind of the big ones that at least on my list are Sage's work on Blue Store for sharding the extent map. He gave a really big presentation on that yesterday, so there's a link down in the discussion section of this week's Etherpad. But if you didn't see it, it's really good. You can probably talk more about it after we're done with this. The other one that is really neat is Piotr's crush optimization. It's a fun little way to get a nice performance boost for Straw 2. So that was exciting. Beyond that, there's a couple of other new PRs here. I haven't really looked too closely at the other ones, but yeah. Let's see, a couple of different things updated. I think the FIO engine for object store is really close to being merged, or ready for being merged. It looks pretty good. And yeah, that's kind of it. Sage, were there any other ones here you wanted to talk about?
I don't think so. With the crush one, we just need to run it through QA Suite. There's actually a set of CLI tests that just verify that the mappings haven't changed. So that's the main one. But I just marked it needs QA, so it'll go through the whole test suite. I think it's a good idea for any crush change. The shard extent map thing will merge shortly.
Are you still seeing the memory problems that I was seeing, Sage?
I haven't looked yet. I haven't looked.
Okay.
So I'll try to reproduce that today.
Cool.
Maybe I should harass. There's that 8824 at the bottom, the use course time in the log. I'd really like to get that one merged actually, but I want Adam or somebody with some good C++ food to deal with that, so it can be a runtime option. Okay. Should we talk about encode to code?
Sure. So in my quest for trying to make all of this somewhat faster. I stumbled a little while ago on a group variant encoding, which basically is, instead of like taking every single byte that you're walking through and using one of the bits to tell whether or not another byte follows, and kind of shrinking the encoding that way. The idea here is that you take a prefix, and in the prefix you store a certain number of bits for whether or not a certain number of bytes follow for given types. So like for 32-bit values, you can store 4 kind of length prefixes in 1 byte. For UN64T, you can do 2, or you can do 5 in 2 bytes. So this is nice for a couple of different reasons. One is it's pretty straightforward in terms of what the encoding and decoding looks like. So it's I suspect quite a bit easier to do for the compiler. But in addition to that, one of the things that we can do is like take the 24-bit case and say, screw it, we're just going to use a 32-bit value for that because it doesn't happen that often. And instead, in the prefix encode, that 0 is just a 0 value. So now if you have like a UN64T that actually has a 0 in it, instead of encoding that in a full byte, you can actually just encode the 0 value in 3 bits. Yep, 3 bits of the prefix. And you could do the same thing like for a 1 if you have a really common case where like 0 and 1s show up, but you potentially need like the full 64-bit range. But usually that doesn't happen. Then you could make a specific encode optimization that steals from the higher values and encodes that in the prefix.
So you're using like 1 byte for 4 values and you use 2 bits per value?
For UN32T, yes. But for like UN64T, you need 3. Or you could do 2 if you were willing to like, not get as much granularity. You could do that too. So it's kind of all about knowing what your typical range of values is going to be, and then you can be smart about how you use that first prefix.
Yeah. Okay. Yeah, I think we need to look at the places where we're gonna where we need particularly space efficient encoding now. So, and then figure out what the patterns are going to be. So in the new code, sent map that matters. So it's already using a bunch of sort of specific bit flags for the fields of the extent reference. But then the blob is just calling regular encode. What does the blob do? Let's see. And that one, we're encoding extents, which are using the LBA encoding currently, flags, and then a bunch of stuff that's optional. I don't know that they're going to help a whole lot there. So we should figure out what other places we have sort of space sensitive stuff. I think the main one is like PG stats, but I don't know that we should be doing anything very smart there because we need to think fast.
Well, the hope with this, right, is that if you use the group var encoding, it should be both fast and space efficient, because it's pretty simple in terms of what the overhead of the encoding is, and also it
that makes sense.
Especially if you have 0 values, you're only doing an encode once on like potentially like 4 or whatever.
Okay.
The nasty thing about it though, right, is that there's all kinds of like potential combinations of things you could do. Like you could have maybe like two 64-bit values and three 32-bit values that you want to encode. So how do you do that smartly? And I'm hoping that maybe with some template magic and overloading that I could have it like choose smart things behind the scenes and just kind of go off and do it. But it's
maybe.
Yeah, exactly. Maybe.
Yeah, I think you got to write each one probably. Okay. I wonder if we should find a case where we're going to use it and then optimize for that case instead of like implementing a library of functions that we're not going to use yet.
My test case right now is actually pextent t in the existing BlueStore code, which is just a really basic one where it's a 64-bit and a 32-bit value.
Okay.
And that's not an ideal case for this, which is one of the reasons why I'm using it here to see if it's actually helping at all in a not ideal case.
Yeah. Okay. Okay.
Yeah,
and it's not working right now. It's funny.
Right, but that case, the reality is most of the time the length of the p extent is duplicated somewhere else, and you'd be better off optimizing that way than treating this as a micro optimization.
I agree with you, Alan.
I suspect most of the places that we're dealing with here, I mean, most of the literature is about encoding sort of random numbers that are uncorrelated. Most of our space optimizations are going to come from noticing correlations in the data and detecting those. Things like, gee, there's no hole in the L extent array, so half of the I don't need the offset and the size. I only need one of them.
Mm-hmm. Yep.
That I suspect is going to, it's the old story. You can do micro optimization or algorithm optimization, and usually the algorithm is the big winner. And I think that's clearly true here. I think that we got to pull all the tricks out of the bag to eliminate essentially redundant information in the data itself. And then once that's done, then we can worry about fancy ways to encode it. I suspect those will turn out to be secondary issues.
Yep. I mean, the big one that worries me now, actually, with the sharding in place, I think the encoding that we have right now is going to be decent. The thing that worries me, I think the next big space optimization is actually going to be the pgstat-t, and that's a big fat algorithm optimization where we have to just not update it every time, or break it into the parts that are updated frequently and infrequently, unfortunately.
That's probably actually a good test case right now for this as it currently stands, because there's a bunch of like 64-bit values in there that
like
it's like exactly. So if you can just walk through those, if assuming that we needed to keep them or we wanted to keep them, the current behavior, that would be a good case for this, right? Because you're now
that might be
5 of them at a time.
Yeah.
Well, this might be a case where a custom merge operator gets what you want because you've only updated 3 out of 50 fields. So, you record those 3 deltas and the rest are gone completely. I think the real issue is are those fields really needed to be in the PG stat? What's the update frequency of them? The question really is do the fields need to be updated on every transaction?
Yeah.
That's the real core of the issue. And, that either they do or they don't. If they don't, then I think you have a whole different set of possibilities for optimization.
Yep.
I'm not sure if I agree with the need or don't need characterization though, right? I mean, there's need and there's, well, it'd be nice to have.
Yeah, but a nice to have if I think it boils down to crass consistency. if the stat is slightly off across a crash, that's either a problem or not a problem. And if it's not a problem, then batching these things up and updating them, every 10th operation or every 50th, is a pretty simple optimization that leaves all the rest of the code intact. But if it actually needs to be updated on every transaction from a crash correctness, that's a different problem. Now, I suspect most of those fields they're nice to haves, but they're not needed for crash correctness, and could probably just be updated lazily, split out into a different data structure or something like that.
Well, the problem is that we update them every time because when they mismatch, that means there's a bug. But I think we can still separate the frequently updated versus the infrequently updated. I think that's going to be the win.
If there's value in having them crash correct, then we should strive to maintain that.
Yeah, exactly. Unfortunately, merge operators don't help because we're several layers up the stack. This is an attribute on an object that's stored in the O node. So we can't really put it in its own custom key space without a bunch of like weird hackery. But I think it's going to be sort of tedious, but it's certainly doable to just separate the fields that update every operation from the ones that don't. I think that's the way to approach this, and it's not going to be that bad. But it's going to happen up in the OST. But even when we do update the part that's not frequently updated, I don't know. I don't know if it's worth it. It might. The group encoding might help there. But I don't know that it's going to be that big of a win if it's really is an infrequent update. I guess for some operations it'll be common. Anyway, okay.
Well,
I think that's probably the best next step though, is to look at that. How to get the PG stat updates separated into two parts.
I guess I check. I mean, the backward compatibility issue around that is troublesome to me. I guess the concept of using the merge operator, I guess I would encourage revisiting that, because that could be backward compatible.
Backward compatible between what?
Existing layouts. I guess people are on RocksDB in file store. You could preserve that code or preserve those existing data. Otherwise, you've got a version conversion that's nasty if you start splitting the
This is the way that the attribute is stored locally on the OSD internal collection object. So it's owned by the local instance of the OSD. It's never shared across OSDs. And those have to be recreated anyway once you. No, I guess okay. I see what you mean.
No, I don't think that's. I think you have a disformat compatibility issue that's going to get super ugly. Okay, and I suspect you're going to end up pushing that down fairly low in the code, anyways. I'm just saying that it might actually be easier to do a merge operator, even though you might have more code that you change. The complexity is not terribly high, and it does support the old layouts.
So you'd like create a new object attribute operation that's instead of set attribute, it's merge attribute, and you'd surface that through the whole.
Something like that.
That could be interesting.
Or update adder or something like that.
Yeah.
I guess
in
one question.
The merge operator has to be like a clean summation over like a vector or something in order to be sort of sanely defined. And that structure is anything but. It does have a lot of UN64s, but they're buried and mixed in amongst a bunch of other objects that are variably sized, so it doesn't really lend itself to that yet.
I guess the question I have is, okay, we're talking about, doing things like separating out things that need to be updated all the time versus things that don't need to be, going through all this to figure out what does, what doesn't. Is it really less work to go through all of that, or, less work to see if some encode decode optimizations are good enough for the time being to kind of let us
kick the can down the road?
Yeah.
Yeah, I mean, if you're already in the middle of this, you might as well look at the object stat sum t or whatever, and just see how it does. But I think it's inevitable. We need to do that change anyway with the incremental updates. So
maybe it is worth doing it now. Then I just wasn't sure how much we wanted to take on in one chunk, kind of.
Yeah.
The big thing the predominant big thing I'm seeing is we're spending CPU time. We are just burning CPU time on anything that requires small encoding, small I/O in general. So, whatever we do.
Well, that's all. That by the way, that will always be the case. I mean, the small I/Os are going to be CPU limited by definition.
Mm-hmm. What I'm worried. So what I'm worried about is that we still are have to update these shards, the extent map shards, and there's still, a kilobyte-ish of encoded data that needs to be re-encoded on every I/O, and those are full of varants. So I wonder if we should look at just looking at the varant code that we have, and either optimizing the same, bit pattern layout or whatever, or using something that's slightly less efficient space-wise, but more efficient CPU-wise there.
Yeah, there are definitely some schemes you can do with the MMX instructions that will, if you're willing to abandon, say, a minimum 1 byte encoding, but say that your minimum encoding is say 2 bytes for small values, you can do some things that are really fast with the MMX instructions. Where you create a byte mask that's 1 bit per byte that tells you which ones are zeros or not. With a few MMX instructions, you can basically encode and decode, again, with just a couple of instructions, a 64-bit value. You can make those very cheap. What you give up is that you have a minimum of a 2 byte encoding for small values, which do happen frequently.
Yeah. Well, the most common small values are 0.
Yeah, now 0 does fit in 1 byte.
If we already drop that out, then right.
Yeah.
Well, Alan, what you were just talking about sounds a lot like group varant encoding, but only with a single value. If you take that prefix, though, and basically use it for multiple values, then you can kind of shrink your encoding down, especially for like the 0 case, right?
Yeah. I mean, there's lots of variants where you can make a bit be a pair of bytes, for example, and encode 2 64s at once. I mean, you can extend that paradigm. Yeah, I agree. I think. But I suspect though that I'm wondering if it's actually. Well, so first of all, the existing variant itself could be sped up dramatically by unrolling the loop. First of all, guys, let's be realistic here.
Exactly.
And that alone would be a huge performance boost relative to what's going on. But I guess what I'd say here is that have we examined it in the context of the sharded O node and the appender improvements to understand if that's still something that's a sufficiently large portion of the problem that merits extreme measures to go address it. I would throw in unrolling the existing encodings, or into that loop also. I mean, I think we're a long way from requiring a revisit of that.
The appender is basically the huge win here. The way that we're doing the byte encoding right now is just crazy slow.
Yeah.
So that's the big one. That's like a over twice as fast once we do that in the existing Blue store. No idea about the new one, but
I'm saying the appender or the encoding.
So the appender, when we use that, like basically throughout the entire blob, we get like a 2x improvement by doing that, just because all of these byte appends are so incredibly slow in the existing scheme.
Right, but we know that's kind of a case we don't care about. I mean, the new sharded code is going to behave very differently with respect to that, and you're going to sort of measure it after these things are applied.
Well, so in the shard map, Sage's shard map code, and what I was able to get to run, because I can't get through a full test, unfortunately, due to it running on memory, but it still looks to me like potentially that will provide some speed up. Maybe not to the extent that it did, but we'll see. It was faster, but not as.
Which that?
The appender I think will still provide some benefit.
I have no doubt of that. I think you have to assume that we're applying that. I think you have to look at this particular question after all these things are done. I guess I'm skeptical that the low-level int encoding, once the current ugliness is fixed, is actually going to make that much difference in the greater scheme of things. Because I think with the sharded encoding, you're going to cut the shard size itself as the biggest way to go solve that problem. I mean, I doubt a kilobyte of shard is going to turn out to be the right number.
I think we just need to sequence these things before we do all the stuff that we know that we're going to do, before we do the stuff that we're not sure whether it's going to help. So let's merge the sharding stuff. I think obviously the current small loops can be unrolled. That seems like a no-brainer. And that's like an easy baseline to do, so I would do that right away too. And then let's focus on getting the new framework that includes fixing the appender stuff in place. I think those are going to be the biggest wins. And then after that, then we should look at where our time is being spent, and then so we can invest our time sort of intelligently.
The history of these things is that when you do these things, you get a different picture after this stuff is done. And I agree. I think you need to do that.
Sage, I'm still wondering about the zero case, though. I mean, that's the big thing, right? With like varint right now. Well, let's use a couple things with varint.
But it's, again, most of the cases where we see zeros, we already have a special case in the encoding path that spends a bit somewhere else to skip that.
Right.
Like in the extent map encoding, I already reserve 4 bits in like the very first value to like skip a bunch of fields that are predictable values.
Okay. Yeah, that's where the real win is. Exactly, that's where the real win is going to happen.
And like PG stat T.
That one, I think the win is going to be storing a separate structure that's just the commonly updated fields, and having the OSD sort of deal with that at a higher level, so that it doesn't have to re-encode the full thing all the time.
Okay, so you don't see too many cases where we need to have something updated regularly that also would have like
have a huge vector of stuff. No, I mean there are the like internal stats in BlueFS are doing that, but it's like literally a vector that isn't even encoded, and it has a merge operator, so it's like it's already cheap. Okay. So I don't see any case right now that's like going to be that isn't possibly to probably already going to be addressed by some other change that we have on the roadmap.
Okay.
So I would wait. But unrolling the small encoding decoding loops, I think is an easy one. And also as part of that, the instead of calling append for each byte, you can just put it all in a local variable in the stack. not even a variable, but like I can answer whatever on the stack and then do one append at the end. That'll also help a lot, even with the current code.
Yeah, I mean that was actually kind of the route that I had gone with it. But kind of the optimization that I ended up with it that I didn't like that much, but was okay, was actually switching to this model where you have a prefix in like the first 2 bits for like a uint32 or whatever, and then doing either 6 bits to put it into a byte, 14 to put it into uint16t, or
I think not even changing.
Studies, I mean, the problem with those studies is that they're all on sort of randomly distributed numbers, which don't really apply for us. You know, for example, things that are offsets, things that are disk addresses have a different distribution of data that,
yes.
and a different optimization. Okay, so 4 ints in a row is different than 2 sizes and 2 disk addresses in a row. Okay, and if you're going to get down into that level, I think you're going to find that paying attention to the actual usage data type rather than the declared, int type, I think is where we're going to find the real win. Because I suspect you're going to find, for example, with a disk address, that disk addresses are almost always going to be 5 bytes, almost always. You're not going to have any value in having even supporting the case of something that's 3 bytes or 2 bytes. It's just a waste of encoding space.
Yeah, I mean, it's going to strongly depend on the field and what the distribution of value that we expect there.
Right. Which
exactly.
which plays to the current scheme of looking at it on a per field basis. Rather than trying to combine multiple fields with some kind of template wizardry, which I think can certainly be done. I'd like to, again, I think there's a fair investment of energy there, and I'd like to see us get these other things out of the way before we go tackle that. Which isn't to say it won't come back.
Okay. But yeah, I still think, right, we should just focus on the stuff that we know is going to help and is simple first, and then go from there.
Let's get your thing merged, Sage. Let's get the memory issue worked out, get it merged, and I'd be happy to go back and start working on that one again.
Okay. Verada just sent me his latest branch. It's not building it. He has some questions. So I'm going to review that next, and probably get Sam to take a look at it too. Because I think that's probably going to be the next big step. But I think in the meantime, the thing that we can do that is a known good win or whatever is just to unroll those loops in the small.
Yeah, I mean, right now, as it stands, it will.
The optimizer should do that anyway, right? Actually,
it might be able to.
Yeah, maybe not. Yeah.
I wouldn't bet on it.
Yeah,
I would not bet on it.
Okay.
But
you've got too many cases where you're rewriting through pointers that just blows its brains.
Yeah. Okay. 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 Do we have anything else before we go back to work?
I may have missed. I'm sorry. I may have missed the first little bit, Mark. You said you were running some of the tests with the sharded code. Did I hear that correctly?
Yes. We're leaking memory right now, but we are seeing some improvement over the existing code. Not as much as what we get when we use the existing code with like really significant appender changes, but it's doing pretty good in terms of performance.
Okay, that's encouraging.
It maybe like a 20 or 30%.
Sounds like a memory leak probably won't take long to track down.
Yeah. Yep.
It's not a really, really obvious one, but it might be obvious for someone that's actually written the code. So,
well, it may not be a leak. It may be a data structure that needs to be trimmed.
Yeah, it might not actually be an explicit leak. It's just kind of uncontrolled growth.
Yep. All right, sharding is merged.
Okay.
Yay!
Sounds good. Now let's figure out why it's broken.
Autocracy's rule.
All right, sharding step map, optimize, and I think that got. All right, cool. All right, I'm gonna run.
Sounds good.
Thanks, guys.
Anyone else have anything they want to talk about before we leave? All right. Have a good day, everyone.